All right, welcome everyone. I think it's time to kick this off. Thank you for making time today. Today's Kubernetes Fortnight session is with Platform 9 and Statehub.io. We will be jumping into some pretty cool storage replication, high availability DR type stories, all on Kubernetes running in the cloud. And this is, as always, about any Kubernetes cluster, right? Not just Platform 9. Today's demos will be using Platform 9, but Stathub will work just as well on any other cloud-based Kubernetes. So hopefully you all enjoy the session. As always, we have some ground rules and means for engaging with us during this session live. There is a Slack channel where you can jump in and ask questions. That's slack.platform9.io. If you're not signed up, sign up. Also, feel free to shoot questions over within the Zoom chat. Always open to answering those. And if you're feeling really brave, you can raise your hand and we will unmute you. If we do that, we try to limit those questions a little bit just to make sure that everybody gets a chance to ask questions. As always, these sessions are for you, our attendees, so please make this interactive. If you have a question, jump in and ask. And today we have myself, Chris Jones, and the Platform 9 team, your common Fortnight hosts, David and Mike, are here as well. And from Statehub, we have Michael and Yuri. I'll let those guys jump in and introduce themselves. If you're new to these fortnights, I'm a product manager here at Platform 9. I look after our Kubernetes platform. And I'll hand it over to Michael.
Hello, everyone. Good time of day, wherever you are in the world. I'm Michael. I'm the head of product at Statehub, and with me is Uri. You want to introduce yourself real quick?
Yeah. So hi, everybody. I'm Uri. I lead the DevOps here in Statehub and do a little bit of customer success and etc.
Great. So I guess if you let me share my screen. Yeah. All right. So so we're going to kick off with some slides and then get some hands-on going and show you what we can do in terms of high availability and DR in the cloud for stateful applications, and not only for high availability, but any kind of scenario where you need application mobility. Indeed, Statehub is a service that allows you to take your business and data anywhere in the world in real time. That means that if you have stateful workloads working on any cloud provider, currently we're available in AWS and Azure, and coming the first quarter of 2022 in GCP as well, you can actually take your stateful applications, databases, MQs, Kafka, the like, file servers, whatever you have, and simply move them from cloud to cloud, from region to region, just by applying your regular YAML files, your manifests, your help charts, as you would. So we've completely decoupled the data from its physical location, and we've created sort of a kind of a container registry experience, but for your persistent volumes and your stateful data. So why would you need to move your applications from place to place? Business continuity, disaster recovery is the first one. Just 2 days ago, half of the internet went down because someone sneezed at AWS, and with it, a lot of applications and services. And part of the reason, if not a major reason, why they couldn't continue operating in a different cloud in a different region is because their data is tied to that physical location. It's very difficult to move large quantities of data and keep them replicated and synchronized between multiple locations. By the way, do you guys hear me or am I talking to myself? Just want to make sure.
We hear
Loud
you
and
good.
clear.
Great. Another common scenario we hear a lot from customers is vendor lock-in, or vendor or the will to be vendor independent. This is especially important in times when it's the cloud providers are competing with one another all the time. They have new features, they have price differences. You want to be able to have your business agile and be able to move from one place to another, regardless of what the current climate it is in your cloud. You want to be able to protect yourself from spikes in prices or spikes in demand or bad service or whatever it may be. 10, 15 years ago on on-prem, people would say you don't want to get oracled, right? Meaning that someone 20, 25 years ago signed a contract with Oracle, and from that point on, you're stuck. You can't get your data off that platform. So you don't want to get Amazon. You don't want to get Azure as well. You need to be able to move your stuff from place to place so that you can maintain your competitive advantage and your business agility. Now, you also want to be able to do all of that without having a degree in storage, if there was such a thing. Data replication and data mobility is extremely difficult, and especially in the public cloud. And we kind of understand that there's not a lot of know-how in this sphere in the world, especially with the need to know more and more things about the specific cloud vendors you're working with. So you want to be able to focus on what your company does best and not deal with a lot of storage stuff. If you look at solutions like Portworx or OpenEBS, they come with some features of replication, but you need to understand storage, you need to understand networking, and you need to be able to set aside weeks, if not months, to go through their 200-page installation manual to get these solutions working. We need a solution that's simple and doesn't require a lot of work and maintenance to get going. And with this comes, of course, the reduction in price, because your time is very valuable to you, to your employer, and not being required to deal with infrastructure work is, of course, going to be much more cost efficient. Also, of course, you can play on the differences between cloud, the differences in prices that the different cloud vendors offer. So you can take advantage of credits that the other cloud providers give you and move your applications back and forth. You can look where spot instances are now cheaper and move your workloads there, if only you could. So our solution to all of this is application mobility. We allow stateful application mobility in the cloud. Now, I'm just gonna show you a demo real quick of what I mean by that. Sorry, I just took a sip of water. What I mean by that is that here's an example setup, right? We have two clusters, one in US West 1 in AWS, another one is in Azure, and it's a coast-to-coast configuration. And we have two stateful applications and a bunch of microservices, right? We have a MySQL and we have a Mongo, and they're replicated, they're replicated in real time. Now, what happens if for some reason, for any reason at all, I want to move my entire operation from one coast to another, from one region to another, from one cloud to another. What happens if US West 1 goes down? Or if conditions on the Azure region become more favorable, right? So basically, I just need to start my applications as I normally would on the other cluster, and then I will have my setup running there. The replication direction will reverse, right? So this is what Stathub does. It does the replication of the data in real time, and we provide all that as a service. So unlike other storage solutions out there that require you to install storage software on your clusters and manage the storage attachments and the RAIDs and the storage pools and all of that, we require none of that. Imagine, if you would, an EBS-like approach, meaning that you request a disk from our service, and it gets attached to your cluster, to your application. And everything that's written to this EBS, quote unquote, like device is automatically replicated to your other locations without you having to do any setup, especially in the networking realm. You're trying to solve a data problem, but data replication usually comes with most of the work dedicated to actually establishing networking and communication between your clusters, between your locations, wherever they are. It's bad enough when it's within the same cloud, but if you want to do anything multi-cloud, that's gonna cost you a lot in time and resources. With all the storage management and the redundancy and the copy management and the replication, kind of a all-in-one approach, we just give your application the storage that is globally replicated to wherever you need it. And then you can move it around as you wish. Now, let me show you what we have here. So, did I hear anyone trying to interject? Got to be the other me.
Good stuff.
In
Keep
my
going.
head. Okay, so we got a few clusters here. I'm going to be showing you a couple of demos. So we have two clusters that are in this one, and these would be the East US 2 cluster in Azure and the US West 1 cluster in AWS. I see that we might have a problem with the cluster here. I'm not sure. Let's see if it works anyway, you know, whatever happens. So we have like a simple application here, right? Running two databases. One is for the orders and the other one is for the inventory and the product catalog itself. And we can see right now it's being served from AWS. We have a load balancer here. Yeah, I see that there might be a problem with Azure here, but we'll see in a minute. So we have a load balancer here on Cloudflare, which is, you know, not on any of these clouds, right? And it will route the traffic to the cluster that's currently running the application. So what we're going to do is we're going to look at the back office app here. We can see again when it's where it's running. It's on AWS, and I'm going to go here and run some simulation of orders, right? Just so you see orders are coming in, we're seeing them in real time. Right now, if we look at our pods, what we have is our store app. We have our MySQL and we have a Mongo. And how they are configured, I have my databases here. The way they are configured is that it's just two stateful sets with one replica, nothing really out of the ordinary here, and, you know, clear text, root passwords, It's a big no. Don't be like me. Don't do that. So I have a MySQL and I have a Mongo. Really like simple basic stuff. We can see that they are using persistent volumes, right? So we have a volume claim template here. It requires a 10 gig volume. It's called DB data, and we can see them here. So it's a persistent volume claim. I'll go deeper into how it actually works in the next segment. So
I was going to ask, Michael, is that using a storage class, or are you?
Yes.
It is.
Yes, I'll go deeper into that. But you can see here that it uses the Statehub storage class here, and I'll explain what exactly it means, right? So if we look at here, this is the Statehub management console, and we have what we call a state. A state is a placeholder for your application data. It can have multiple volumes, and it can span multiple locations. So you see, I have my default state. This is something that you get out of the box when you when you sign up for Statehub. It currently has 2 volumes, and it is in 2 locations, US West 1 and East US 2. We can see drilling down here that here they are. The volumes here, we can see that these correspond with the PBC names that we have here. And since they have this storage class name, we'll go here, we can see that this is how this state will appear in your clusters, right? So orders are still coming in. We're gonna fail over to the other location. We're gonna just run a script that does that. Called switch, and it has lots of colors so we can trace what it does later on. But basically what we're going to do is we're going to stop the store app, stop the databases. Then we're going to fail over to the other cluster and apply them there in the reverse order. Basically that's that, with some waiting for the databases to start and stuff like that. Not really interesting stuff. I bet you can do a better job writing this script than me. Something that we need to focus on here is that we are running this Statehub CLI command here that sets the state owner from one cluster to another. This means that the other cluster now takes ownership of the data. So let's hope it will work, and hopefully the warning there that we saw on the Platform 9 dashboard is a false alarm. So I'm running the script, and we have a lot of stuff going wrong at the same time. What's wrong with that?
What I can do there.
Wait. Uri, any ideas?
Well, it seems like the Azure cluster API is not reachable.
Go back to Platform 9.
Yeah. Oh, everything's online.
Show me the errors again.
Yeah, able to recognize.
What type of kube config did you grab?
The usual one. It worked.
Token or password?
An hour ago.
I think you just
token. I grabbed it.
The tokens are
Just like
24
that.
hours. So if you grabbed it,
I grabbed it
yesterday,
like
it might have expired.
3-4 hours ago.
Oh.
Yep.
This is the fun of live demos.
To quote Bill Gates, this must be why we're not shipping.
Do you want me to try and?
Oh, I know what happened. Yeah, I know what happened exactly. So here's the thing. Here's a Statehub thing. So currently, because I have 2 separate demos, I'm using 2 separate two separate Stathub accounts. And right now I'm trying to work with an account that is not configured here properly. So let me just grab a token real quick here. I'll do Stathub login. I'll go here. Yep, my bad. I'll grab a token so I can run my CLI properly. And Stathub show state. Let's see how it works. Yep, okay, we're great. Let's switch. Yeah, so orders are running. Now I'm running this and it will break everything. Right, so I'm stopping my store and we can see the 503s coming in. So service temporarily unavailable because now the load balancer has nowhere to route. What happened was that we stopped the store, stopped the databases, we set the owner of the default state to the other cluster, and now we are starting the databases. It's going to take like half a minute, and then the store application will run again. So we're moving from AWS US West 1 to Azure East US 2.
So to be clear, these databases, they didn't even exist on you're switching over to Azure. They didn't even exist over there. Like you weren't even paying for anything, right?
I mean, the application wasn't running at the moment. There was a live copy of the data that's running, that's being updated live the whole time. Okay, we're back, and so the data is synced between the two locations. And you see, we switched to Azure. Orders are coming in again. So basically, we took a stateful application coast to coast with all of its data. We didn't lose a single transaction, and yeah, that's pretty cool. Now I'll tell you how we did that. I can stop this now, and yeah, and the load balancer kind of reconfigured and everything works. Cool. So platform 9 is okay. This was a false alarm indeed. And yeah, so I'll log out here for the second demo I'm going to show you in a minute. So how do you get started with Stathub? How do you make this whole thing work? So you create an account on statehub.io. We're going GA next week, but you can get early access if you let me know, or I'll give you a link to sign up. You download the Stathub CLI, and then you just register your clusters. Currently, we support any Kubernetes cluster on Linux that's running in AWS or Azure. People who run Kubernetes on Windows, why? Now, after you register your clusters, you can start your applications as you normally would, and all of their data is protected, is in sync between all of the locations where your clusters are. Stathub lets you move states between clusters. So again, what is a state? It's a collection of volumes of your stateful stats, of your deployments, and so on. And it's a definition of the locations where you want the data replicated in real time. And these states show up in your cluster as like, under your organization. It's going to be the name of the state dot the name of your organization dot statehub.io. So if we see again here, we have Stathub. Sorry, we have kubectl get storage class, and it will tell me that I have the default state under the Platform 9 POC organization that we saw a minute ago in the GUI. If I go to the other cluster, yeah, now I'm on the Azure cluster, and I run the same command, I see the same thing. Now that means that all volumes that are created, all persistent volumes, right? Get PVC. All persistent volume claims that are created in this storage class, no matter where they are in the world, point to the same data. So basically, this is the state. It's the data and the locations of the data. That's kind of a definition. Now, how we do that? So the Stathub data fabric is a global service. We provide you the infrastructure, the service. You don't need to do any work to connect your clusters to one another. You don't need to do any work to connect the cloud locations to one another. That's very complicated and costly, and that's my job, and you don't want my job. Better do what your business is good at, and leave the data replication shenanigans to people who really want to deal with this, like us. So we have come up with this concept of a global PVC, right? Of a GPVC, a global persistent volume claim. A persistent volume claim, if you use a storage class, like, I want my persistent volume to be on GP2, the volume is called DB data, and I have here like some clusters on one region, on another region, there may be in different AZs. Every time I apply this to a cluster, I will get a new volume with a new data, right? So there's no way for me to refer to the same data from different clusters, let alone from different locations in the world. Now, with the Stathub data fabric, you have this storage class name, which is a definition of your state, and this volume will refer, this persistent volume claim will refer to the same data on any cluster in the world. It means, imagine like a CDN or a DDN, whatever, right? A data distribution network, which means that you get a volume close to your cluster, specifically in the same cloud region as your cluster, that is identical to the data that you have in a different location, in a different cloud, in a different region, and you can refer to it by the same name in both of these locations, and you will get the exact same data when your application needs it, right? So this is the global PVC concept. Now, I won't bore you with too many slides, but if you have like a few applications, for instance, again, a Mongo, a MuSQL, yeah, sorry for the typo, a MySQL, a MinIO, right? You want to create a multi-region and multi-cloud kind of DR scenario. What you would have to do if you have done it yourself would be to create a network, somehow bridge the connection between the two clouds, right? Or the three clouds, if you want Google as well in the mix. And then, you got to secure that network. You got to deal with the BGP routing. You got to probably go to some physical location through ExpressRoute or Direct Connect, because you don't want to go through the internet. That's expensive and not secure. So this is something that would take you a month to set up. And I know because we actually did that, so you won't have to. And then only after you finish with your network, because again, your data problem is first and foremost a network problem, then you got to deal with the replication mechanisms for each and every one of your applications. So you need a Mongo DBA, and you need a MySQL DBA, and you need someone who understands MinIO replication, and you need to configure all of these data flows and what happens when this is now the primary location or this is now the primary location. So all of this is a lot of time, right? And a lot of money, of course. So, like, it's if you just do a rough calculation, it's gonna cost you in human hours almost $20,000 just to set it up, just for the work you do, right? Plus the surplus compute cost to run databases on your secondary locations, on your standby locations, whose job it is only to receive the data and dump it to disk, right? That's also kind of wasteful. And you know, in contrast, you can have Stathub, and the network is taken care of. You don't pay egress. You don't pay the people to spend the time to set it up, and you don't even need the clusters to exist on a secondary location. So this is kind of a contrast of what you could have with Stathub, or what you would have to do on your own if you would try to achieve multi-region and multi-cloud redundancy and high availability setup, right? And this is our installation guide. This is all you need to do. You just need to register your clusters with Statehub. So that means that if you have two clusters in two different locations, two or more, but let's start with two, you go to the first one, you register the cluster, the state is expanded to the location where this cluster is, and then you go to the second cluster and you register that. I'm going to show you in a bit how it works. And then we'll see where this cluster is, and we'll expand your data fabric, your personal storage network, to this other location as well. And from that point on, real-time replication has already been established. So when you apply your application manifest, what will happen is that a volume will be created in both locations, and every bit that will be written here will be immediately replicated to the other location as well. So when something goes wrong, you give ownership of the data to this cluster, and you start your application. And then the replication direction will reverse, and you will have basically your application running here. Of course, if this site is still down, we will buffer all the changes and bring this location up to speed when it comes back, right? So you will never lose any data. And let me show you what I mean by that. So we have two other clusters here. We have actually three, but I'm going to use only two of them. Let me go here to the other demo folder. Let's see.
While he's doing that, I just want to remind everybody, please, this is an open forum. Any questions that you have, anything you'd like to learn more about, maybe double click on, you're wondering about, please put it in the chat, ask. We'd love to talk about it. All questions are welcome.
I would actually love to hear about your use cases, what you think you can do with Stathub, and a potential, like, you know, and offer you a potential solution. So I have another Stathub account here called PF2. Who's PF2? PF9 demo. Right. Let me log in and get a token here. So I'm just reconfiguring my CLI tool to work with the other account. And now, yes, Stathub list clusters, and I have nothing. Yeah, so this is a blank one. Good. So I'm going to go on and look what I have here. I think this is a, yeah, this is a brand new cluster. It's empty. I'm gonna do a register cluster on it.
You need the kube config for that, right?
Yeah, of course. The CLI reads your kube config and lets you like decide which context you want to operate on. So I want this one. I'll choose a name for it within the Stathub system. I'll need to install some Stathub components. Again, it's not like a storage management software. It's just, you know, some stuff to access our for your cluster to access our API. And it asks me now if I want to use the default state with this cluster, and claim ownership of it, sure. And now it says that it needs credentials. Stathub doesn't need credentials to do anything on your cloud, but we write, we create a user. I'll start doing this, and then I'll talk while it's going, while it's working. Your cluster needs the ability to access your Stathub storage securely. So what we're doing is we're gonna take these credentials that you will provide for us from your cloud account where your cluster is, and we're gonna store them as secrets in your cluster. So when you start an application that needs that will claim storage from Stathub, your cluster will be able to create a private link connection and basically connect to the storage, which is a good segue to talk about like the way this works. You want to test something?
Yeah, Michael, we've got a question here. Is this feature only for cloud or can be used on-prem?
We're a cloud-only service, at least currently. We're going to, we're considering expanding it to AWS Outposts and Azure Stacks.
What about something like VMware vSAN? On premises, have you looked at anything like vSAN from VMware?
Yeah, it's going to be very difficult for us to support something like that. So currently, it's not an option.
Yeah.
Do you have any? Anthony's asking. Do you have any more? Do you have any like hybrid use cases or any ideas like that?
No, currently it's public cloud only. So the cluster is being registered, and we have recognized its location. So the state is also going to be expanded to this location. So it's going to take a minute to finish. You know, while it's doing that, I'll go and register the second one as well. Oops. Okay, config. Oh, it's done. Never mind. I'll do it here. Register cluster. I'll give it a name. And again, we're going to need some permissions for your cluster to do certain stuff. Now, the Stathub CLI recognized that I have an Azure CLI installed on my machine. So I'm going to run it and get my permissions going this way. I'm going to use this subscription. And let's give it a second to create a service principal. Yeah.
To be clear, your administration before already had some things set up, right? Some clusters and everything created and set up. And so now you're doing it from scratch.
Yeah, I'm showing what it takes basically to set up multi-region, multi-cloud replication, which is basically, you know, going through this register cluster wizard. And that is that. So let me finish this. In the meantime, we can see whether we have already on our AWS cluster, right? If we have the storage class running, not yet. Okay. It takes it a while to register, so we'll give it another second. System. Okay, so it found the state, and the storage class will follow shortly. And so we can, yeah, okay, so we have the storage class. And if we look here, we'll see that our clusters are registered. Each one is in its own respective locations. And now we can see that our default state now spans these two locations, but doesn't yet have any volumes. And it's visible to these two clusters, right? So, and that's how we're going to see it in our clusters. So here again, Stathub, again, storage class. Oh, sorry. Yeah, I'm confusing the two. Get storage class. It's going to appear in a minute. So in the meantime, what I'm going to do is I'm going to deploy an application, again, just for the purposes of demonstration. We have a MySQL service. It's a MySQL stateful set, and it's going to request a volume here. So what I'm going to do is I'm going to just apply it. And now we see that we have a volume that's being provisioned in both locations, right? This started immediately. So this is going to take about a minute, I would think, to provision, and then we would have a database running. By the time this finishes, we'll be able to see that the, we have here on the Azure cluster, we have our storage class already. So container is creating.
So Anthony was asking, he just wanted to confirm that this is, when you say on the public cloud, you're talking about the big three, right? The big three clouds, and that's it.
Currently the big two, the big three will be supported in Q1. So like within 2-3 months, we're going to have Google support as well.
Okay.
Yeah, and that's
Anthony,
Michael. That's constrained to where you're operating the platform, correct?
Yeah. If there's a big enough demand, of course, we'll consider other
clouds
as well. Cool. But currently, I haven't spoken to anyone that wanted any of the other ones, right?
Yeah, I mean, we met at KubeCon, and the survey that the Platform 9 ran, the vast majority of the 560 people that completed that survey said, EKS were actually where they're running. So it wasn't even sort of doing native clusters like Platform 9 or K8s.
Yeah.
EKS.
So we do support those. We do support EKS. We do support AKS. We will support GKE, Platform 9. Maybe the other ones, but K8s is supported. So like as a generic cluster, it's not going to be a problem. This is
I think that's an important topic to touch on. It doesn't matter if the Kubernetes control plane is managed or not, right?
No. As long as it's a Kubernetes cluster running on Linux, it will work.
Yeah. What happens if you have Windows worker nodes?
Nothing. It won't work.
It won't work.
So yeah.
It catches on fire and just throw it out the window. Yeah.
Yeah, I hear .NET Core is really, really crushing it right now. And everyone's running it on Linux.
Yeah,
it is.
Develop on Windows, run on Linux.
I heard MS SQL runs better on Linux than on Windows. So
everything runs better on Linux than Windows.
We'll get back to this in a minute. In the meantime, I can show you some other configurations that you can achieve. So you can have no standby cluster, right? And this way, it means that what you do is you register one cluster, but for the other location, you just add it. Like you just add another location without having a cluster. And this means that you can save money, but by not running any compute resources at all, just pay Stathub for the storage, but not actually spend any compute resources, right? And so if something and then you have still your replication, and if something goes wrong, then you deploy a cluster on the other side. Then you register it, set it as owner, and apply your application, and then it comes back to life. Another thing you can do is you can have two-way replication. You can have half of your workloads running on one location, another half on the other one, and then have two states, one owned by this cluster, the other one is owned by that cluster. And if one goes down, then the other one is taking over all of the workloads, or the other way around, right? So you can do this. You can do a three-way DR, having a third location on standby with two of these replicating to be between all of these, right? So you can have a situation that you really want to protect yourself from any possible outcome, and so
this makes me think I'm working at a bank again.
Well, this is why a lot of banks are not going to the cloud, because they have these replication options on their very expensive like EMC machines, right? And you have nothing like that on the public cloud, or at least had nothing like that.
Yeah, I mean, no one's done block replication, right?
Something crashed. I'll need to check what happened. That is unfortunate. Huh.
I'm currently.
Sorry, we got a few minutes left. If anybody's got questions,
You can try and just deploy another volume with a different name.
Yeah, sure.
So if I was deploying if I was going to, let's say I'm using Helm to deploy my apps. So in the values.yaml file, I just specify the Stathub storage class that I've created, and everything gets handled through Kubernetes doing the dynamic provisioning using the storage class as well. That works fine.
Yeah, of course. This is exactly like a storage class is a storage class, and so the behavior is completely the same. Anyway, I think
Michael, for a moment, can you touch on performance? We had a question here, and asking about latency and that sort of thing between all these different replications.
All right. So what we have in terms of latency is a situation where what you have between the application and the disk is comparable to what you would have between your application and EBS, which is usually sub-millisecond and even less. So it all depends on locality and on which AZ everything is. So you can have you can have your application running in the same AZ with your with the storage, or you can have it running on any other node in a different AZ. So this would vary, but in that case, it's still sub-millisecond. Now, between the locations, we of course replicate asynchronously, but in real time. So that means that nothing stays in any buffers. It's not snapshots. It's not any of these stuff. What you do get is about a few hundred milliseconds delay. Now we're coming up with a feature soon that allows you to have multiple copies of your data in the same location, in the same region, in different AZs. And in this configuration, what's going to happen, I'm just going to show you the pricing slide for a second, because it kind of illustrates that. So if you have 2 copies of your data in one location and 2 copies in another, what will happen is that your application will write here, and we will replicate synchronously to another AZ. So of course, you get more protection, but at a cost of a bit of latency. However, what then would happen is that from here, it will get replicated to the other locations. If something happens, right, what we saw again in US East 1 the other day, the failure of the region was not instant. It's not like, North Virginia was wiped off the map. Heaven forbid this didn't happen. And actually, in my recollection, there was never a case of a region going down immediately. You still have a couple of seconds for us to evacuate your data, even if connectivity with one AZ is gone, your data will go out to another location. So you will have effectively an RPO of 0 in this configuration over any distance for most failure scenarios. And if not, then you might you might have a delay of a couple of hundred milliseconds. So it's all in this range of latencies. This is why we don't offer active-active kind of configurations. First of all, because file systems really don't work that way, and the ones that do really don't, and nobody uses them anymore. And the other reason is because you cannot do that over large distances like we do. Yeah. So something errored out, but Mongo did come up. So right, I can see it here. Right. So this one is stuck. This one is running. But anyway, if I'll
yes, it's stuck because, as always, it's hard to delete stuff. It's harder to delete stuff rather than creating.
You know what I'll do? I'll go to the Mongo here. And because I'm not a Mongo admin.
If you create the MySQL with a different name, it will probably work.
Never mind. We don't have time. Where is the data folder? Here? Yeah. I will just leave a file here. I think this is the mount point. Data/db. Right. This is the mount point. Whoops. It's the GUI playing tricks on me. Yeah. Yeah. So let's just echo hello into hello.txt, whatever. Yeah. And then what we'll do, just to show you, like, it's it's a real replication kind of thing. What we'll do is we'll delete the Mongo from here. We don't have to, but I want to just take it back and forth for a second, and I'll give the ownership of my default state to Azure West US, right? I can do it even from here. I'll do it from here. Yeah, set as owner. Yes. Okay, now it's the owner. And then I'll switch. Good. And I'll apply my Mongo.
What happens if someone somehow managed to deploy the app active on both clusters simultaneously?
It will work on one and not work on the other. So it will only work on the owner.
So it'll fail to get the
it'll get an IO error because it won't be able to mount the file system.
Even beforehand, we will not create the PV. Our CSI will not create the PV.
It will error out. It will, you can see the logs that it's not owner. Yeah.
That will be is that an event? Is that an event on the driver? Like, how would I troubleshoot that as a user?
I could explain how the CSI works. Basically, once your container goes up, your pod, you apply your deployment or stateful set you have something like you apply your PVC with it, PVC or the PVC template with it. Once the PVC goes up, it sees that its provisioner is us because it uses our stateful our storage class, and then it goes to our process which is running inside your cluster and tells it, hey, please create this volume for me. And when like the checklist before creating the volume, we check that the current cluster, the token that we have, owns the state right now at the moment. If it doesn't, it will just not create the volume.
So
Yeah.
where's that data logged for the user? Like if they're trying to troubleshoot something, where would they go?
So we are currently trying to publish only relevant events to the user. It will be on Kubernetes events, so kubectl get events.
You will see it here. You will see it here that it's not
on the
it's not an
events
owner.
on the pod, on the events on the PVC,
Oh, cool. Yeah, that's what I was looking for.
and some
Yeah.
stuff could not. If you need to dig a little, like even deeper, you can always go to the Stathub system namespace. You'll have all our containers and pods running over there, and you can just check out the logs of each component.
Yeah.
Yeah, so we can see that we actually read the persistent volume on the Mongo container, but at the other cluster in Azure. So, like I added another line here, and I'll switch it back. Yeah, so I'll go to my AWS and Stathub set owner default US East. Good. So by the way, here's our CLI. Yeah, it shows. Yeah, it shows that there's a problem with the other volume. It failed to provision. But other than that, Stathub show state default. So it'll show you some problems that we know that we have, but we see that the Mongo volume is okay on both of the locations. And this one just failed to provision for some reason. We can later delete it, right? So we can delete it. These things sometimes happen. So so we went from AWS to Azure, from west to east, and then from east to west, and then we took the application back and again apply Mongo. Now you see that I apply the exact same YAML file, right? Because as we said, we have this global PVC thing going on. We don't even specify here storage class, because the default behavior of the cluster registration is that we put our own storage class as default. Of course, you can override that on the command line if you so wish. And now we can see that the active location is again on AWS, and the Mongo is running. But since I don't know any Mongo commands, I'm stuck with showing you file system operations. And like I with MySQL, I was planning to create tables and stuff. But anyway, this is Stathub. This is the state of affairs right now. So other than this minor hiccup, I think it's all pretty cool. And the pricing is fairly simple. You get you pay 10 cents per gig per month. Performance-wise, we're talking about general purpose storage at the moment, so similar to GP2, GP3, Azure Premium SSD. Wow, it wasn't supposed to be a rhyme. Anyway, so with this, you pay another 20 cents for each additional location. So if you have 2 locations, you pay 20 cents. If you have 3 locations, you pay 40 additional cents for that, right? So if you have just 2 copies of your data, each one in a different location, that's 40 cents per gig. If you have a situation where you have 2 copies of the data in 2 AZs in 3 locations, it would be 60 cents per gig. The feature of having multiple copies per location is also coming out next quarter, so it's already in the pricing. Anyway, if you want to test this thing for your own needs and you want to play with it and potentially give us some feedback or not, you can get up to 100 gig free pretty much perpetually. Not for production use, obviously. You're not going to get any support for the free tier in 2 locations. So it's like a limitation that we only support specific locations in free tier, and you cannot have more than 2 replicas in 2 different locations. So you can sign up for this at statehub.io/start, or you can shoot me an email. Actually, I would love for you to shoot me an email and tell me about your use case. This is it. Any questions?
I think not. This is a cool session. We should definitely do a follow-up on some application design stuff, so people can sort of think a little bit more about how they would architect this into their applications.
Yeah, basically you can add cross-region and multi-cloud replication to any application. The application doesn't know it's being replicated. The clusters don't know that they're being replicated. It's just, you register your cluster, and from that point on, it's all everywhere you need it.
Cool. All right, guys, we are slightly over time, so I think it is time to wrap up. As you saw, this works really well with Platform 9 and Statehub. So if you have any questions for either, hit us up on Slack or shoot an email. Once again, thank you all for your time, and we'll see you next year. I don't think we have another one of these for the rest of the year. I could be wrong.
This is it. Nope. This is it.
This is it.
Happy holidays.
We will.
Indeed.
Yeah, you too.
All right.
See you guys next year.
All right. Thank you, everyone.
Indeed. Thank you very much. Goodbye.